Now, again, the purpose of this lab, I like very much to let you know why we're doing what we're doing. The purpose of this lab is to prove to you that if you don't carefully measure things in a laboratory, you could get hurt bad. I mean, really bad. This is a full functional laboratory. It may not be a professional lab like you would find, say, in a clinic or in a drug research facility, but it is a lab, and we are professionals at what we're doing. And there are chemicals here. It's a standard high school chemistry and biology lab, but there are chemicals and equipment here that could really, really hurt you. When we do labs, I try not to do anything super dangerous, but even with a safe lab, if you screw up with measurements, you can hurt people, yourself. And you can make funny colors in your skin. All kinds of interesting things. Lose fingers and toes, eyebrows, whatever. Okay, so pay attention to how important it is to measure properly. That's the point of today's demonstration. Okay, so let's have everybody pass out. If you'll pass out to a pair of goggles to everybody. And if you're standing back there with the video, you're fine.
Okay. Just like scooch up, Parker. Just like scooch all the way up to the line, please. Thank you.
Yeah, go ahead and put them on. And don't worry too much about adjusting them. If they're a little bit loose, just hold them against your face. This won't take very long. So we do need eye protection because
You're going to get something in your eye.
Fire and some other fun things. Now this is not going to make huge amounts of sound. It's not going to scare you really bad. And yeah, your goggles can go right over your glasses. Good.
Okay, good.
I have these on right?
Yes. On your eyes, that's,
Not ear goals.
Eargles.
Just making sure.
Somebody invent that, please.
Okay, so,
They're called earmuffs.
I don't know if you guys can see this powder, this kind of gray charcoal powder. That is not gunpowder. It's called calcium carbide. And see how little there is? It's just a few grains of it. That's how much? How much is that?
A couple million.
Now you're allowed to read to learn. What does that say? 10 grams. Notice that the decimal is in a specific location. If it was in a different location, that would be a very different measurement. 1.0 grams is a lot different than 10.0 grams, right? Decimal locations matter. And in this case, it's not just a worksheet where you might get a wrong answer in math. That can blow off your hand, that kind of mistake. Okay, so let's talk about this lab. What we're going to do with this chemistry experiment or demonstration is set ice on fire. So ice can burn. Let me put on my extra safety equipment. Now, the instructions for the lab gave me a specific amount of calcium carbide that I was supposed to use. On purpose, I measured the wrong amount. This first demonstration is going to be with not enough chemical.
Ready?
Whoa.
Okay, so that's kind of cool. The ice is on fire.
I have seen everything.
You heard a little whoosh sound, but it's over.
Is it burnt?
It's over. It's not very.
I should really just get that on camera.
Not
Should I
as
just...
impressive as we hoped, but that's because I used the wrong amount of chemical. Now, this second trial is with 2.5 grams, still a super light amount of material. There's not much material in there. Remember, a penny, just a single penny, only weighs a couple of grams. That's not much matter. So here we've got 2.5 grams of calcium carbide. And this is the proper amount recommended by the experiment. We'll put some ice in there. Yep. That's the way it's supposed to look. Ice on fire, fire and ice. Now, you heard a whoosh. Did you feel a little bit of heat maybe on your skin?
No. Just a titch.
Just a little bit.
Yeah, just a little bit.
Now, I'm going to put too much chemical. 5.0 grams. Still, it's only just a few grams of material. It's not that much, see? Just a tiny little bit. But it's too much according to the experimental procedures. Now, what I want you to do is pay attention to the way your face your mouth, your neck, the skin on your neck, your ears. Pay attention to the way your chest feels. Pay attention to temperature and pressure. Okay? When you have too much chemical with something like this, let's see what happens. So I have not measured properly, and what did you feel?
I felt
Heat.
heat.
I felt
Heat.
You felt
I felt
heat.
steam.
I can
felt
still
heat.
feel
You
it.
felt heat.
Yeah.
Did you feel a little bit of a pressure, a little bit of
Yeah.
a push?
Yes.
That was an explosion. A tiny one that I controlled on purpose so that it wouldn't kill anybody. But it was a very controlled, small-scale explosion. Where the other one was just fire, that was an explosion. The fire isn't what the explosion is. The explosion is a pressure wave where the air pushes against you at a distance. And you can feel the heat on your faces, right? So, an explosion, the danger isn't the fire. The danger
It's a pressure wave.
is the pressure wave.
Very good.
That could have
So-
shattered into like a grenade.
With a grenade or a brick of TNT or whatever kind of explosive you might prefer,
Can we take
the
glasses off?
concussion wave, the pressure wave of air, you can go ahead and take your goggles off now. The pressure wave, as it comes away, the gases expand from the explosion, and that the gases push on the air in the room. And the air pushes against you. You could feel it on your face and your chest, right?
Yeah.
And you felt the heat of it. That was just a little bit too much of that chemical.
What if you
If
had
I had put maybe 10 grams, let's say instead of the 1.0 grams, I had misplaced the decimal on accident. I put it one place too far to the right, so I measured out 10 grams and put it in
Oh.
there. That may have been enough with this type of reaction to shatter the glass and send sharp bits of glass shrapnel into the audience.
I'm glad you didn't do that. Yeah.
I'm glad I didn't do that too, because
try not to.
that'd be paperwork and we'd have the mop and
And I like
so,
you, Mr.
we
Patterson.
actually do like you.
Mr. Patterson's number 2 enemies, paperwork and mopping.
So, do you understand?
Don't get on their back.
Remember, the purpose of this demonstration was to help you understand. Okay, look at me, please. The purpose of this demonstration was to help you understand that if you don't measure properly, you can hurt yourself or others really bad. You must not only follow directions and use the lab skills appropriately, you must not only do math appropriately and never misplace a decimal, but those measurement skills that we didn't get right on the test, those measurement skills that I'm going to reteach you, you have to measure properly every time you do an experiment, or you could really get hurt. Are we clear?
Yes, sir.
All right. Let's go ahead and put the eye protection back in the box. We're going to wipe those down with some Clorox wipes in just a moment. Let me put my protective gear away, and then we're going to discuss the theory behind what you just saw.